Pull up a tomato transplant that has been in the ground for 1 week, and the root ball tells you everything. White threads branching out in every direction, dense, reaching, holding the soil like it belongs there. Now, pull up the one next to it. Same bed, same week, same watering. Sparse roots barely anchored, leaves already starting to pale. The only difference between those two plants was a cloudy liquid poured from a jar before the second one ever went in. That liquid cost less than $1. It came from the grocery store baking aisle. Most gardeners know this moment. You put a seedling in the ground with every good intention, water it carefully, wait, and nothing happens. The leaves go yellow at the edges. Growth stalls. Sometimes the plant collapses within a week. Sometimes it just sits there, suspended, looking miserable, neither dying nor growing, while the plants in every YouTube video seem to explode overnight. So you walk into a garden center looking for answers, and the shelves are stacked with them. Transplant fertilizer, root stimulant, starter solution, rooting powder, mycorrhizal inoculant. Some of them are genuinely useful, but most gardeners are buying solutions to the wrong problem. They are treating what they can see, which is the leaf, the color, the stem, when the real decision was already made underground, days before any of that showed up. Here is what the visible symptoms miss. A yellow leaf is not a leaf problem. A stalled transplant is not always a water problem. A plant that will not grow is often reacting to something that happened at the root level before the first sign ever appeared above the soil line. The leaves are showing you what the roots decided. By the time the leaves are telling you something is wrong, the root zone has already been struggling for days. This matters because most gardeners go straight for what they can see. More nitrogen spray, more fertilizer, more water. But if the root system is not working, it does not matter how much is poured on top. The plant cannot use what it cannot absorb, and it cannot absorb efficiently when the biology around the roots is inactive. Roots need more than soil and water to function well. They need oxygen, and they need a living community of microbes around them that can break down complex organic material into the simpler forms the plant can actually absorb. Most garden soil, particularly in beds that have been worked, amended with synthetic fertilizers over the years, or left dry and compacted, does not have the level of microbial life it once did. The nutrients may be present in the soil, locked inside organic matter, but nothing is converting them. The pantry is full, but the kitchen staff has gone quiet. Beneath the surface, roots also communicate through chemistry. Plants produce natural compounds called auxins, particularly one called indole 3-acetic acid. Think of auxins as the signal that tells root cells to divide, to push forward, to branch outward, and build more surface area for feeding. More feeder roots means better contact with soil, better water uptake, better nutrient absorption. When this signaling is working well, the root system expands. When it is suppressed, or when the soil biology that supports it is missing, the roots stall, and the plant stalls with them. This is where baker's yeast enters the story. The same small packet of active dry yeast you buy for bread. Saccharomyces cerevisiae. You can find it in every grocery store, in the baking aisle, usually in strips of 3 packets for under $2. Older gardeners in parts of Eastern Europe have used yeast solutions in the garden for generations. It was passed between kitchen and garden without much formal explanation, just the observation that transplants settled in faster, that tomatoes seemed stronger in the weeks after the liquid was poured in. It had the feel of a grandmother's remedy, and for a long time it was treated like one. But yeast is not just sugar and fermentation bubbles. A packet of active dry baker's yeast contains protein, free amino acids, B vitamins including B1, B2, B6, and B12, potassium, phosphorus, and magnesium. The amino acids in yeast are a directly available form of nitrogen, the kind that does not need to be broken down through a long conversion chain before a plant or a microbe can use it. The B vitamins, particularly thiamine, are associated with root development and help plants manage stress responses. The mineral content is modest but real. And then there is something more specific. Certain yeast strains, including Saccharomyces cerevisiae, have shown the ability to produce indole 3-acetic acid, the same type of oxygen that signals root tip division. Research published in the Journal of Pure and Applied Microbiology and supported by multiple plant biology sources has confirmed that yeast can act as what scientists call a biostimulant, a substance that supports plant growth not necessarily by feeding the plant directly, but by triggering or amplifying biological processes. The mechanism is real, even if the scale in a backyard garden is not as dramatic as some videos suggest. Here is the first twist worth paying attention to. When you activate dry yeast in water and pour it around the roots of a plant, the yeast is not feeding the plant. That is not what is primarily happening. What it is doing is more interesting. The yeast cells, once active, release their internal compounds into the soil water, including those amino acids, those B vitamins, and those auxin-type signals. But more importantly, the yeast begins to feed the soil's existing microbial population. Bacteria and beneficial fungi already present in the soil respond to the sudden availability of simple proteins and organic compounds. They wake up. They multiply. The invisible workforce that has been quiet in sterile or depleted soil begins to function again. And as that microbial activity increases, locked nutrients start converting, root zone chemistry improves, and the plant's own root signaling has something to work with. So the system looks like this. Yeast activates in the water. Yeast feeds and stimulates the soil. Microbiome. The microbiome becomes more active. The root zone becomes more biologically alive. The roots respond. The plant above the soil responds later. This is also where the second twist comes in, and it catches most people off guard. A quick word about the sugar. When you make this mixture, you add a small amount of sugar to wake the yeast. Many gardeners assume the sugar is going into the soil to feed the plant. It is not. Sugar has almost no direct benefit for plant roots. What it does is give the yeast cells the simple carbon they need to become metabolically active, to shift from dormant powder into living fermentation. The sugar feeds the yeast. The yeast feeds the microbes. The microbes feed the plant. The sugar is 3 steps removed from the visible result, but it matters because without it, dry yeast activates much more slowly and releases far less into the solution before it is applied. Now here's the other question, the one worth asking directly. If this works, even partially, why is it not sold in a bottle on the shelf next to the root stimulants? The answer is not complicated, and it has nothing to do with suppression or hidden knowledge. It is a logistics problem. A live yeast solution in water starts fermenting almost immediately. It produces carbon dioxide. It changes in chemistry hour by hour. The living activity that makes it useful in the garden is precisely what makes it impossible to bottle and sell. Within 1 day of mixing, the solution begins to shift. Within 2 days, fermentation has peaked and started to decline. The biological window you are trying to use is a matter of hours, not months. A shelf product must be stable. It must survive a warehouse, a shipment, months on a store shelf, and still function when opened. A living biological preparation cannot do that. The shelf requires stability. Biology requires freshness. These two things are in direct conflict, and that is the real reason this preparation stays in the kitchen instead of the garden center. To make it, you need a jar, 1 packet of active dry baker's yeast, 7 grams, 1 tablespoon of sugar, and 1 liter of water that is lukewarm, somewhere around body temperature, not hot. The temperature matters more than it sounds. Hot water, even water that feels only moderately warm, can damage or kill the yeast cells entirely. The result looks identical to a properly made mixture, same color, same jar, but the biological activity is gone. You would be pouring nothing useful into the soil and never know why it failed. The water source also matters when living microbes are the point. Chlorinated tap water poured directly can suppress both the yeast and the existing soil biology you are trying to stimulate. If you are using tap water, let it sit in an open container for 30 minutes first. This allows most of the chlorine to off-gas naturally. Rainwater works well if you have it. Stir the yeast and sugar gently into the warm water. Do not beat it aggressively. Then leave it undisturbed for 20 to 30 minutes. What you are waiting for is a light foam forming across the surface, small bubbles rising slowly, and a faint bread-like smell rising from the jar. That foam tells you the yeast is alive and metabolically active. That is the window you want. Do not seal the jar with a tight lid while this is happening. A fermenting mixture produces gas, and pressure can build unexpectedly. Leave the jar open or loosely covered with a cloth. Once the foam appears, dilute the activated mixture before applying it. For a soil drench around the base of a plant, mix 1 part of the yeast solution with 5 parts of plain water. For a light foliar mist on leaves, dilute further to 1 part yeast solution in 10 parts water. This dilution matters. Pouring an undiluted yeast solution directly onto roots can temporarily stress the soil chemistry and can, in some conditions, compete with the plant for available nitrogen as the yeast itself breaks down in the soil. Apply it in the evening or early in the morning. Midday heat is hard on the plant already, and it changes how quickly the liquid moves through the root zone. Pour it slowly around the base of the plant, not directly onto the stem, not in a fast flood that runs off the surface. You want it to move gradually into the soil where the root zone actually is. Apply it to moist soil, not bone-dry soil. Roots under severe drought stress absorb differently, and pouring a biological solution onto completely dry roots can be counterproductive. This is where some gardeners go wrong in a way that is easy to miss. They make the mixture correctly, they apply it, and then they make it again the next day because it seemed to help. More is not better in this case. The yeast solution is a stimulant to a biological process, not a fertilizer you can increase freely. Applying it too often, too heavily, or to the same plant more than 2 or 3 times in a single season can disrupt the microbial balance you were trying to create. Once the soil biology is active and working, it does not need another large dose every few days. It needs time, organic matter, and reasonable growing conditions. There is one more mistake that many gardeners make, and it is the kind of mistake that kills the results before they start. They make the mixture, then get distracted, and use it the following afternoon. By then, fermentation has peaked and the biological window has narrowed significantly. The solution may smell sour or sharper than it did when the foam was fresh. Use it the day you make it. Within a few hours of the foam appearing, while the living activity is at its strongest. As for which plants respond best, the evidence and growers' experience both point consistently toward heavy-feeding vegetable crops. Tomatoes, cucumbers, peppers, zucchini, and strawberries are the most commonly cited, and the logic makes sense. These are plants with large root systems and high nutrient demands that depend on constant uptake throughout their growing season. A more biologically active root zone makes a more meaningful difference for a plant that is asking the soil for something every day. Transplants and young seedlings during the first week or two in the ground are also a strong candidate, because this is when root establishment is most critical and most fragile. Leafy greens can respond if the underlying problem is microbial availability rather than an actual nutrient deficiency. Perennials and established trees respond more slowly, if at all, because their root systems are large, already established, and less dependent on a single application in the root zone. Here is where it is worth being honest about something. There are videos online that show this method producing dramatic overnight root growth, plants that doubled in size, transplants that went from near death to thriving in 48 hours. That is exaggeration. It does not serve the gardener, and it does not serve the method. What the research suggests, and what the honest evidence supports, is that a properly made yeast solution, applied at the right time and to the right plant, can support root zone biology in a way that may improve transplant recovery, may support better root establishment, and may provide a meaningful boost when the timing aligns with the plant's actual biological need. Under the right conditions, with living soil and organic matter present, and with a plant that still has functional roots and living tissue, this method can make a real difference. But a plant whose roots have fully rotted, or a plant that is in completely sterile sand with no organic matter, will not respond the way the dramatic videos suggest. The method works with plant biology. It does not override it. The first visible sign that it worked is often not dramatic. It is a stalled plant that simply starts growing again. It is a transplant that stops looking pale after 2 weeks instead of 4. It is roots you see when you lift the pot that are denser and whiter than you expected for the time. The result begins underground, and the above-ground evidence comes later. That dense root ball, those white threads branching thickly through the soil from a transplant that had only been in the ground a week, that was not magic, and it was not an expensive product. A jar, a single packet from the baking aisle, a spoon of sugar, warm water left to foam on the kitchen counter. The garden does not respond to what costs the most. It responds to what the biology around the roots could actually use, right now, when the roots were deciding what kind of plant they would become. There is another common grocery item that works on a completely different mechanism entirely, one that works above the soil line rather than beneath it, and the biology behind it is just as surprising.